Here we have a contactor. Contactors are typically used for motor starter circuits, especially three-phase motors. So I've got one here that I've dismantled, but let's look at it in this before it's been pulled apart and have a look at all of its connections. So coming in the top, we bring in our three lines, line 1, line 2, line 3, which in New Zealand would have 400 volts between them. Then over on the right hand side we have a set of normally closed contacts, number 21 and 22. What that means is there's a circuit from 21 to 22 right now, and later when the contactor is energized, those contacts go open. Down the bottom here we have A2. A2 is the contact to supply the coil that energizes this contactor. Up top here we have A1 and another A2. Just gives us that flexibility of where we bring our other line or our neutral connection to the other side of the coil. This particular coil here is a 240 volt 50 Hertz coil, and they can be swapped out quite easily for a 400 volt 50 Hertz coil if you're using a 400 volt control circuit. Down here we have our little clip for our DIN rail to release it off the DIN rail. And down the bottom here on our outgoing contacts, they're typically referred to as terminal 1, terminal 2 and terminal 3, and the thermal overload unit would connect to those three terminals, and then we would go from the bottom of the thermal overload unit out to the motor supply. So I've pulled it apart. This is quite easy to take apart. There's just this screw here and this screw here. The spring is to keep the contacts apart, and the coil here, when energized, pulls these two pole surfaces together, and in doing that it closes the contacts. You'll notice a little ring here on the I'll just turn it over a little bit to have a better look at it. This little ring around here is to prevent the chatter that could take place. It's like a shading ring on a shaded pole motor. It's to prevent the chattering that can sometimes happen on these contactors when the pole surfaces are touching each other. So have a look inside here so what we can see. Get a little view of the contact arrangement. You can see there when we pull this, the contacts go together or apart depending on which ones we're looking at. So it's what we call an electromechanical device. Contactors are used everywhere you have motor, three-phase motors requiring starting, for example, direct online motor starters, star deltas, reversing motor starters, primary resistance, secondary resistance, auto transformer, all sorts of motor control circuits. We use contactors to actually supply the heavy current to the motor and a small control current working the coil here, which electromagnetically brings the contacts together. So these contactors come in various sizes. These are just general purpose, really small size one. You can get these things going, really large, really big units, hundreds of amps up to, quite a few hundreds of amps. When we get up to larger values, we may use an air circuit breaker on a larger machine, but these certainly do go up quite a large size. Another feature of the contactor compared to a relay, which does a similar job, is that the design of this contactor allows for the contacts to come apart and not have any problems with flashover between the contacts. So they're able to open circuit fairly heavy currents. You can also see the laminations here of the poles, and that is to reduce the effects of eddy current losses, which would cause heating of the cores here, of the magnetic cores. So that's just a little bit of a view, if you like, into the inside of our typical motor contactor. A little bit hard to focus on here to get an idea of the AC and DC current ratings of the contacts. This one might be just a little bit clearer. I'll just hold it on there for a moment so you've got something to pause and look at. Again, this is one of the Chint brand of contactors. They stand up very well, to be honest. And are reasonably priced. So thank you for viewing, and hopefully that helps you with a little bit of an understanding of the insides and the electromechanical operation of these contactors.